Now that we've had some experience looking at Newton's second law for horizontal motion, let's start looking at vertical motion. Now this doesn't really change how Newton's second law applies. The only thing we have to be a bit more conscientious of now that we're in the vertical direction is we have to be conscientious of the force of gravity. So we're just going to look at a couple of examples for vertical motion, and then a little bit later we're going to start to talk about weight versus apparent weight, but that will be saved for a separate video because that topic's a little bit more challenging. So let's see what we got in this first example here. We got a 0.100 kilogram steel ball. It's dropped in a graduated cylinder full of glycerin. So the magnitude of the drag force, which can be thought of like a force of friction acting on the ball, is 0.789 newtons. We want to determine the acceleration of the steel ball in the glycerin. Alright, like anything in dynamics, we always want to start with a free body diagram of what's going on. Well, we have our ball in the glycerin. Now the first thing is, this thing is going to experience a force of gravity. Because the force of gravity is going to pull that ball down through the glycerin. What we've been told, though, is that there is a drag force of some kind. So the drag force is always going to act to oppose that motion. So the drag force is going to go up. So we have our two forces. We have this Fd going up and we have this Fg going down. Now for direction purposes, I would usually say the direction of the net force, call that positive. So where is the greater force? Well, the greater force is going down, so it's probably in my advantage to call down positive. That'll help me out. Or at least I find that to be most helpful, especially later when we start to do things like pulleys. I find that very helpful. So what we want to do is we want to write our net force statement. So we know that the net force on this object is the force of gravity plus the drag force. Now, we know our definition for F net. We know it's mass times acceleration. We know our definition for Fg. It's mg. And the drag force we are provided in the question. So the objective here is to find A. So what we want to do is we want to solve for that. We're going to divide both sides by m. Now, keep in mind we have multiple terms here, so we're going to divide this whole thing by m. And the other thing is you cannot cancel this m with this m. The only way you're allowed to cancel something from the bottom with something on top is if that term appears in every term up top. Since I don't have an m here, I'm not free to cancel it here. You have to be able to cancel it from every single term. So what we get here is we get that the acceleration is this mass times g plus this drag force, once again divided by this mass. So the only thing we have to be careful with, again, we want to be mindful of direction. We've called Fg down, so g is going to be positive 9.81. We've called the drag force up or negative, so when we enter that drag force, we're going to enter it in as a negative number. So the last thing we want to do is we want to actually calculate this. So I have my mass, 0.100 kilos, times positive 9.81 meters per second squared. And then again, we're going to add that negative 0.789 newtons. And then we're going to divide this by 0.100 kilograms. So making sure that we divide by that negative, making sure we include that negative, that is really important. So I'm going to just say going up. Because if we don't put that, we're not going to get the right answer. So let's calculate that. So if I do this really carefully in my calculations, I'm going to get about 1.92 meters per second squared, which is good. But this is acceleration. Acceleration requires two parts. We need a magnitude and we need a direction. Now, because this came out as a positive number, and we've also called the down direction positive, all we have to do is tack on that direction. So we can say the acceleration of this thing is about 1.92 meters per second squared down. And that's the key with the question. Magnitude, direction, and being mindful of your signs. So the second question here, this one's a little bit more challenging, and you'll see why in a second. So we have a skydiver. They're going to jump out of a plane. So before they open the parachute, they're going to notice that the magnitude of air resistance is about 300 newtons. So this time we're told that the acceleration of the skydiver is 6.72 meters per second squared down. We want to find the mass of the skydiver. So this one's a little bit more challenging. Once again though, we always want to start with our free body diagram, because we always want to see what's going on. So this skydiver, well, or any skydiver, when you jump out of the plane, there's certainly going to be a force of gravity trying to bring you back down to the earth. Now, since this skydiver is accelerating, they clearly haven't reached terminal velocity yet. This means that their drag force is not going to balance out the force of gravity. So we're going to have this drag force, or we've called it air resistance. Call it what you want. I'll call it F air. Now again, we want to assign a direction for positive convention. Since the force of gravity is going to outdo the force of air resistance, let's just call the down direction positive. Again, I really encourage the direction of the net force to be your direction of positive convention. Alright, same thing again. We're going to write out our net force statement. So the net force acting on this skydiver is the contribution of the force of gravity and the contribution of this force of air resistance. So we have MA equals mg plus F air. Now the problem that we have this time is we want the mass, but you'll notice that I have a mass term here and I also have a mass term here, so I have mass on both sides of the equation. The only way that I can work this out to get mass as one single term is I have to have all my masses on one side. What I'm going to do is I'm actually going to bring this mg term, I'm going to bring it to the other side here. So I'm going to subtract mg from both sides. So I'm going to subtract mg here, and I'm going to subtract mg here. So what I'm going to get is I'm going to get ma minus mg equals this force of air resistance. So the key is, if you have the term you're trying to isolate for in more than one term, bring all of those terms to one side. Now that I have all the masses on one side, what I can do is I can factor m. So I can factor this mass term out. So I'm going to get the mass factored out. And then what I'm going to have left in brackets here is I'm going to have A minus G. And this is equal to F air. So this is good. I have one solitary mass term. I can isolate that by itself. So having this mass term by itself, to get it by itself, we just have to divide what's in brackets here. We're just going to divide by this A minus G, and we're going to do that on both sides here. So what I'm going to get is I'm going to get that the mass of this object is going to be the force of the air resistance divided by the acceleration minus gravity, or the acceleration due to gravity. Only thing we have to watch out for, make sure we're careful with the signs. So the force of air resistance, it's going up. We have called down positive. So this 300 newtons, it actually has to go in as a negative. Now before we finish, you might start to freak out. We have an m and we have a negative. Don't worry. The acceleration's magnitude is less than the acceleration due to gravity. So the bottom is going to be negative as well. Those negatives are going to cancel out. We've been told the acceleration 6.72 meters per second squared down. So that's going to go in as a positive since it's down. G also going down is going to be going in as a positive. So we're also going to put that in as a positive. So what I'm going to get here is I'm going to get this negative 300 and then divided by this 6.72 minus 9.81. So what we're going to get is we're going to get about 97.1 kilograms. So we can say that this skydiver, they got a mass of 97.1 kilograms, which seems about sensible. Almost just probably about 210, 250, somewhere between 210, 215 pounds. So a little heavy, but nothing wrong with that. So yeah, the only thing with those type of questions, if the term you're trying to solve for appears in multiple places, get all of those terms to one side, factor, and then you can isolate for that.